What's up, everybody? Today I'm going to be doing a comparison between Stellar, XLM, and Internet Computer, ICP. I'm going to be breaking down how they compare and benefit each other. Let's start with Stellar, XLM, a blockchain network focused on fast and cheap cross-border payments, connecting banks, financial institutions, and individuals. And we have Internet Computer, ICP, a decentralized cloud computing platform that enables smart contracts to run at web speed, aiming to replace traditional cloud services like AWS and Google Cloud. How they could benefit each other. Even though they focus on different areas, XLM and ICP could complement each other in a few ways. Number 1. ICP hosting Stellar-based dApps. ICP could provide decentralized cloud storage and back-end computing for applications using Stellar. This would allow cross-border payment apps built on Stellar to be fully decentralized instead of relying on AWS or Google Cloud. Number 2. XLM for payments in ICP ecosystem. ICP lacks a strong built-in payment system for global transactions. Stellar's fast, low-cost payments could be used to pay for services, smart contracts, or NFTs on ICP's ecosystem. Number 3. Bridging traditional finance and Web3. Stellar focuses on fiat on-off ramps, example, MoneyGram integration. ICP lacks a strong gateway to traditional finance. A Stellar ICP bridge could allow fiat to flow directly into Web3 apps hosted on ICP. Number 4. Smart contract enhancement for XLM. Stellar's smart contract capabilities are limited. Soroban is still new. ICP's advanced smart contracts could help expand Stellar's ecosystem, allowing more complex DeFi applications using XLM. My final thoughts. Stellar brings efficient payments and banking connections. ICP brings scalable decentralized cloud computing. If XLM handled payments and ICP powered applications, they could create a powerful decentralized financial ecosystem.
As a young man, right?
A long time ago, 82. You do these things when you're young.
Right.
But look at the world in 1982. It's a lot different today.
Yeah, absolutely.
We didn't have GPS, no cell phones. I mean, it was the old-fashioned Omega navigation, long-range, high-frequency radio. But in our world, we thought it was great because that's all we had.
That sounds hairy. Yeah, absolutely. Dom, I want to talk a little bit about where you see some of the first use cases potentially of the internet computer. Will it be running AI models, or will it be doing other things? Where do you really think, and is there particular industries where do you think you're going to see first advantage?
Well, I think AI will be important to adoption. I mean, there's already hundreds of services running on the internet computer, and they range across everything. And at the moment, there's a lot of Web3, and when you have a network that can run tamper-proof, unstoppable, autonomous code, then naturally, it can be used for applications like DeFi or creating. Actually, there are social networks, small social networks that are now running on the internet computer under the control of digital governance systems. So I think all of that will continue to grow. I think the real adoption is going to come from the self-writing internet, and that's because people can just, will be able to just get what they want by talking in a way to the network. And these applications they'll create are like, sovereign. They're not a captive customer of anyone. They're tamper-proof, so then they don't have to worry about the security, and of course they're updatable, which is actually more of a challenge than it sounds. I think with respect to running AI on the internet computer, at least it will be comparatively efficient as traditional IT, but at the moment, it's less so. And also at the moment, there's limitations on the number of parameters you can use. So we're just getting into large language models now. Previously, it's been just neural networks. You'll certainly see by the summer some reasonably powerful large language models. But the reason that you will want to run a model on the internet computer on a public network at greater expense is that you'll want the model to be immune to cyber attacks and resilient and unstoppable. So imagine the example I always use is imagine a law firm, and the law firm could run a standard open source model like Llama. They're incredibly powerful already. Combine it with something called a RAG infrastructure, which is a kind of memory. It gives the AI a kind of memory, and into that memory, the law firm would place all their interactions with clients, all the emails, all the legal filings, all the filings against their clients, maybe some canonical legal texts and so on, maybe pre-train or fine-tune the Llama model a bit for legal stuff. And now, it's been an incredibly useful resource for the partners of the law firm, and enable them to better service their clients. Now, this will be fantastically useful. They'll better service their clients. They can prepare for trial faster. But imagine if that was hacked. Now this AI infrastructure has become like what I call a hot wallet for data. All this incredibly sensitive data in one place, ready to be exfiltrated. And if that happened, you could ruin the lives of a large number of your clients, and your reputation as a law firm would be toast. So first of all, the law firm will be very concerned about, if they're going to adopt AI technology, how can they ensure this, data exfiltration doesn't happen? And secondly, it might be that before the availability of the model, it might take a partner like 3 weeks to prepare for a big trial. And with the model, they might be able to prepare for trial in a few days. Can you imagine what would happen if, a few days before trial, the partner logged on to the AI to prepare, and it's unfortunately been encrypted with ransomware or crashed or something like that? It'd be an absolute disaster. So there are a lot of use cases like that where people will trade increased computational expense for security and resilience.